Hey guys, so what we're going to do in this video is we're going to show the process of what we're doing to generate components for tool pathing to cut on the CNC. So here you can see a simple cabinet. We've got drawer fronts. We've got a filler here because this lands against a wall, so that's just a 3/4 inch filler for scribe. Then over here on this side we have a panel end. There's the carcass, toe kick area, and the countertop. And this application we actually have two cabinets, a right and a left. And the left side I've already exploded, so we have the carcass, we have the back, sides, top and bottom. Because this is going to get a bank of drawers, we're not going to put any shelf pinholes in this. It's just going to be an open carcass. We didn't draw the drawer boxes in there, but we will take this inside dimension, subtract our 5/8, 5/16 each side for our drawer boxes, and this is the size of our drawer fronts: 5, 6, 7, 8, and 9 and 7/8. So we'll make the drawer boxes for those appropriate. And so what we want to do here is we want to go, so there's our exploded cabinet, there's the cabinet put together, so we're going to have two of these guys. What we've done is we've taken the all of the components. So we have top, bottom, and the sides for these two cabinets, and then these two lighter brown, these are the backs. So we've arrayed those out onto four sheets. We're also going to cut, you can see these long strips here. These are the toe kicks. So we'll pre-cut those so that we don't have to rip those on the table saw because we've got the room in those sheets. So what we want to do is we want to go to our top view here. So now, and this is something that we want to, we're going to, I'll bring up every once in a while, we're going to talk about, is called the C-plane, construction plane. And you can see this, the blue, the green, and the red. This is the XYZ home. So we typically, when we do our 4x8 sheets, this is 96 inches by 48. So this is our home one on the CNC. So as we walk over to the CNC where we started up, this area here, this is where the controller is. So here's our table's actually 5 feet wide by 10 feet long, obviously bigger than a 4x8 sheet. So these are the parts arrayed out in a 4x8 sheet. And what we want to do is these guys, when we're drawing stuff, these guys could be above the C-plane. See how they're up like that? And if you were to tool path this, it would cut these parts above the C-plane. And what the C-plane is when we set our surface off the top of the plywood. We set our surfacing block on there, and we tell the machine where the top of the plywood is. Well, it's going to set that surface, but then if we're doing tool pathing with the parts up here, or even worse, if these guys were to be down there where they're below the C-plane, the machine is going to cut to this level. So what we want to do is we want to, when we array out all of our parts, let's go back to top-down view. So those parts that I had highlighted, like you see, those are below the C-plane. So if we go back to the top view, and we want to give a command up here in the command button. We want to go project. So you see here, project to C-plane. So we hit project to C-plane, select objects. So I'm going to select all of these guys, because those are all of my curves. And then I hit enter. And you see that the choice here, it gives me delete input objects. So if I hit no, what it's going to do is it's going to keep the those guys that were below, but then it's also going to project those to the C-plane. I don't want to do that. I want to have everything just projected to the C-plane, and then anything that wasn't at the C-plane, I want to throw it away. So hit yes. So now when I go back, so those guys there, go back to the perspective view, you can see everything is back there. If I hit the back button here, you can see how there they are. That was before the command. If I hit the redo button, it puts it back at the seaplane. So everything's at the seaplane height here. So now what we're going to do is, so this is our first sheet right here. These are components that we're going to cut for those cabinets. So these are and this is something else I want to show you real quick. So these lines, these are the perimeter of these sheets over here. So the way that we do that is we go to the side view here and see these guys. There's brown and the lighter brown and the dark brown. So let's go to a view where you can see both of those guys. Well, you can kind of see them through the other direction. So see here, that's the large back that's back behind there. But these are the pieces laid out nice and flat. And so what I want to do is, the way that we generate this. So when we bring in our models from, let's take a look at this again. So we have all of these components over here: top, back, bottom, right, left. We've taken all those guys for these two cabinets, and I've brought these over. I copied those and brought them over here, and I laid them flat. And they were all at different heights, but I brought them down so they're all at the same level. And then what I'm going to do here is I'm going to draw a line. So go up here to the poly line. Let's left click, and I'm just going to draw a line across here. And I'm going to take this line and I'm going to bring it up so that it's intersecting or going through all of those parts. And turn that guy off. So now what I'm going to do is, see this icon over here, it says project curves. So I'm going to left click on that, and it asks me select curves or points to project. So I'm going to drag across that. So if I drag across from the right side to the left, anything that my square touches, it's going to highlight. Let me undo that. Let's go back to that command. So I'm going to go back to project curves, and it's asking me select curves and points to project. If I drag this box and come from this side and make a box over it, I haven't highlighted the whole thing, so it's not going to surround that. So, but if I come from this direction, from the right to the left, and anything that touches it, it's going to highlight it. So it asked me about the curve that I wanted to project, and what it's going to do is this curve is going to be projected through all of those parts. So select curves and points to project, press enter when done. So hit enter. Oops, let's do that again. So select curves to project, hit enter, and now it's asking me select surfaces, poly surfaces and meshes to project onto. So now I can highlight, I can just box over all of that stuff, and it highlights everything. And then I hit enter again, and now we're going to go, let's look in perspective. And what it's done is it's everything that line goes through, the perimeter of all of those parts are now highlighted. So if I go back, so what I'm going to do, just to show you, I'm going to go negative 100. So these are the same components that I put over in this spot here, because I just did that prior to. So we don't need these, we already have them. But that's how we do that. Let me delete that. That's how we get the perimeter of all of these parts, is we take that, we project, we go through this guy here, project curves, we project it through all of those parts, and then move those over. I randomly did them because I wanted to, or actually I arrayed these guys out so they fit onto 4x8s as they were these solid pieces before I even did this. But you can actually take the curves and just array those out in the 4x8 sheet also. So we don't need that line anymore, so I'm going to delete that. So now these are this is the perimeter of all of the components. And so if we highlight that and then look sideways, which is the side of the front of the car, we could do it the side, whichever. But we look on there, and you can see there's our 0 seaplane. That's where the X, Y, and Z arrow indicators are. And we know that we're on the seaplane with all of our parts. So let's go back to the top view. So now what I want to do is this sheet here. What I typically do is I move stuff in increments of 100 inches. So these guys here, if I mirror over those, I have my quick buttons set up where the up arrow, down arrow, right and left move in 100-inch increments. So if I go, I just hit the up arrow and it moved everything 100 inches up. Come back down, so my part is in that same spot. So now what I want to do is these are the components that or the perimeters of the parts that I want to cut. So what I'm going to do here is I'm going to go up to machine operations, and I'm going to go to the create miscellaneous operations. So it's a MOPS. Actually, I already had one going there, so let me cut that and get rid of that. So I have a method of operation set. So go back up here and hit 2.5 axis. Click on that. So these are my choices that I want to do. Typically, we're going to do profiling passes and engraving, but for right now, we're going to do a profiling pass. You can see by the icon, the black line is the part that you want to cut, and the blue line is the tool path that it's going to show. And we want that's important because we want to make sure that the tool path isn't on the wrong side. So we want to profile, hit the profile button. And so what happens here is there's a series of commands. Basically, we're telling the CNC everything to do. We're telling it what parts to cut. We're telling it what bit to use. We're telling it what feed rate, what RPMs, all that kind of stuff. Very important information because the CNC is only going to do what you tell it to do. So the first thing I want to do is I want to remove all. So what we're doing is we're generating the regions that we want to cut. So remove all and select curves and edges. So now, like I said before, if I drag a box from the right side to the left, anything that my box hits, even just a little corner, it's going to highlight. If I come from this side and go like this, it's only going to grab the things that are inside of the box. Click again, or I'm going to hit escape. So let's go back up here. If I escape out, I got to go back and tell it. So 2.5 axis, and I want to go to profiling, and I want to hit remove all and select curve edges. So now if I start up here and I touch all of these, some part of all of these boxes, it's highlighted all of those guys. So I did that with my left mouse. So now if I right mouse, it's going to indicate all of those parts, and you can see that there's a starting point. This little icon here is the starting point where it's going to start that region. So I have all 8 of my regions. So that's my first thing, control geometry. So the next thing we're going to want to do is pick our tool. So we're going to click on the tool button. We have no tools loaded yet, so we double click on this, and that's going to bring up this icon here. So we have ball mills, we have end mills. These are where we identify our tools, and we actually already have one loaded. This is but I'm going to go ahead and we'll do a different tool here. I'm going to click on flat mill, and so now we always name the tool. So typically what we'll do is we'll name the diameter. So I'm going to go 0.25 end mill, and then capital T. And our 1/4-inch end mills are always in tool number 5. So I'll name it number 5. Tool diameter, I want to make sure, because this guy is really important. They're all really important, but this one's really important that you get this put in there, because if it says 0.375, 3/8, but you meant to put in a 1/4-inch bit, it's going to not cut the part where you want it to. So we got to make sure that we have the correct diameter there. So that's a 0.25. That's the name of the tool, 0.25 end mill, T5. So this box here is really important. This guy here is really important, and then this one here is really important. So this is the tool number, because you want to make sure that it's grabbing the correct tool. So that guy is number 5. Because what it's going to do is it's going to identify, you've identified you want to use the 1/4-inch end mill for this operation. You've got the correct diameter, and you're going to tell the machine where it is, and that it's in tool number 5. So because we only have a 3/8 compression in there right now, we're going to save this as a new tool and then hit OK. So now we go to our next button. So we started at control geometry, we went to tool, now we do to feeds and speeds. So here We've got, it always defaults to these numbers here. These are things that if you have any questions, ask us. There's some defaults that we have just from running things so much. Typically on our 1/4 inch and our 3/8, I'm going to default to, you know, if the bits are sharp, I'm going to default to about 17,500 RPMs. These guys here, this is the plunge. So this is the, you can see here the plunge feed. That's this portion of the entry. The approach feed, which is the next one, that's where it's starting to enter the tool path. And then the engage is the actual engaging of the part. I typically default to these guys, 75, 75, 75. The cut feed, this is how fast the bit is going to be traveling. So when we're cutting 3/4 inch material, depending on how thick you're going through, if we're going through MDF, we're probably going to be going through at a little different speed than we would be if we were doing plywood, or definitely a different speed than if we were doing like plastic or something like that. But on the cut feeds for plywoods, which we're going to be cutting in this application, we're going to I'm going to default to about 175 to 200 inches a minute. So let's just go ahead and go 175. The retract, this is where it leaves the part. Over here, as it exits the part, I just default those to 75. 75. So we've got our plunge at 75, approach and engage at 75. Our cut, as the bit's going around each one of the parts, is going to be traveling at 175 inches a minute, and then leaving each one of the parts 75, 75. Our clearance plane. So this is really important because it defaults to, you can see this pink box here. This is it creates this pink box over everything that's on my computer screen, anything that would generate or tell it what the height of this guy is. If this box isn't checked, what it'll do is it'll skim right across the top of the part, right about a 1/16 of an inch, sometimes the 32nd of an inch. I like to do the absolute Z value of 1/4 inch. So anytime it leaves the part, if we're on a 3/4 inch piece of plywood and I've set the surface off the top of that piece of plywood, it's going to travel a quarter of an inch above the top of the part. If you've got a bunch of operations like drilling operations and things like that, and you hit like 1 inch or 2 inch, every time it does an operation, and then it's going to move up an inch, which is a lot of Z, and then go across and go to its next place, or if it's doing multiple drilling in one spot, in between each one of the operations, it's going to travel that 1 inch. So it can add a lot of time to your tool path. I like to be safe. 1/4 inch is a good area. There's times where we'll have different thicknesses of material down, and we want to make sure that, say this piece over here was thicker than these guys here, and the machine's coming down from over here, you would want to set your skim plane at the height of this highest part, so that as the bit's coming across, it doesn't run into this one trying to get to this guy. All right, so everything's on the same plane here, so we're just going to go 0.25, so 1/4 inch over the top of all the parts. All right, so we're going to go to our next button, so clearance plane, and then we go up to our next guy here, which is cut parameters. So this guy here, because we're cutting straight lines, this tolerance level here is not really going to be affected. It defaults to this 0.001. If we're doing curves, a lot of times what I'll do is I'll put an extra 0 in there, because when you're doing a curve, it's a series of straight lines to create that curve. And if you're like 0.01 or 0.001, if you zoom way in, you'll see a bunch of straight lines. And if you're cutting something like a piece of plastic or something that's really fine and dense, you'll actually see the little bumps in the cut. And so what we want to do is we want to make sure that the tolerance is appropriate. So here we're at 001. That's fine, because like I said, we're cutting straight lines, so there's not going to be any issues on that. This is a really important aspect right here, is the cut direction. So if you've ever run a router bit, you know when you do a climb cut, it gives you a different attitude of cutting. When we're cutting plywood and MDF and melamine and things like that, I'm going to typically go to conventional cut. If you go mixed, the computer is going to go both directions. When I'm cutting parts with a nice brand new bit, I'm going to get a really good cut from conventional cut. So click on conventional cut. Get rid of that. These are different commands that we're not going to use, but they will have their applications, and we can go into this kind of stuff later on. So after cut parameters, now we're going to go into cut levels. So here, this guy, because we've set the surface off the top of the part here, we know that our material, I've thrown a set of mics on this material, and I know that it's 0.77, it's like 0.768. So I'm just going to go I'm going to go 0.77 is my total thickness of material. And what I want to do is when I cut these parts out, I want to do two deep passes, but leaving an onion skin. And the benefit for that is that when you have a lot of little parts, these are bigger parts, so that they're going to be the vacuum's going to work fine on those. But if you have a lot of little parts, what works really good is to cut these guys out and leave what I call an onion skin. So the vacuum of the table is holding down the complete part. You've cut maybe 90% or 95% through each one of these pieces, but you haven't broken the membrane so that they're still attached. And then a lot of times if I'm cutting small parts, I'll come back with a smaller diameter bit so that I'm not loading the whole bit up and creating vibration, which is going to break the vacuum. But on this guy, what we're going to do is our rough cut. So this first box here, rough cut, if I've got 0.77 thickness here, I'm going to probably set this guy at 0.7, let's go 7.4. And so that's the depth, that's my first depth. And in the rough cut, in these guys here, I want to do this dimension, but cut it twice. So 0.74 divided by 2 is 3.7. So I want to go 0.37. So the rough cut is 3.7, or excuse me, 7.4. We're going to go 3.7. So it's going to do two passes to generate that to get it to 7.4, and it's going to leave 0.03 for its last pass. And then this is another thing when you're cutting a bunch of pieces, maybe a bunch of small pieces. If you do depth first, you can see here it goes 1, 2, 3, 4. So it's going to do all of these passes on one single part. So it'll cut this part out, and then it'll move over to this part, which this wouldn't be a big deal because these pieces are all going to get held down by the vacuum. But on smaller parts, what you would want to do is use this command, which is level first. So now you see how it goes from 1 to 2 to 3 to 4. So what it's going to do is it's going to cut all of these parts at this first level, and then come back and cut again at the second level, and then come back and cut this small little onion skin piece on the third level. And that's a really good practice, because what it does, it takes a little longer because it has to go over to this part. Instead of just staying here and cutting this, it's going to cut one level of this and then go and recut the thing. But you've decreased your chances of a part breaking the vacuum and vibrating loose, which means that you're wasting parts and wasting material. So so we've got our level first, so that's a good operation. So now another command here, our next command, you can see how we just kind of work our way through the little tabs. So we've got our cut levels identified. Now we're going to go to entry and exit. So it defaults to where it's going to see this blue line. This blue line represents the tool path, which you'll see here in a second. That's the center of the bit. So what's going to happen here is this part's going to approach, and it's going to engage and then start cutting. But what it's doing is it's cutting through the outside of the part, and you can control how far out it starts or doesn't start. But what's going to happen is there's a chance that the computer is going to have it enter, but it'll hit this part as it enters to cut that part. So there's two different things you can do. You can either hit none, which it's just gonna plunge straight in right above where it's gonna make its cut, or you can ramp in. So for right now, what we're gonna do is we're just gonna say none, and you see how we go from lines and arc, which is defaults to, so it's entering from the outside. But if I hit none, it just starts right there. It comes over the top and then enters. It goes down to the depth it needs to, and then it starts making its cut. And then the same thing with its exit from the part or retract is it defaults where it's going to exit the part like this. And I'll show you what this is something that's good to identify. So let's go back and let's just do a toolpath with that. So I'm going to click on that guy there. So you have an entry and an exit. So I'm just going to, we've identified everything else. So now let's just go ahead and hit generate. And you can see here how this is the entry and the exit as it's cutting the part. So over here, it's not a big deal because it's going to enter and exit in this waste material. But over here, because this, you can see the entry and the exit are beyond this blue line here. This blue line represents the center of the bit where it's cutting. It's actually going to make a little notch in the part because this yellow line is the finished part. The blue line is the center of the bit. You've crossed over that with this bit, so now you're going to make an indentation in that part, which we don't want to do. So you can see on all these guys, it's going to do that. These are deeper because these are all of my parts always default. We've got a 3/8 compression, so all of my parts are 1/2 inch away from each other. So one bit's going to come through, but it's not going to touch the other guy. And then when it comes through, they'll be close, but you're not going to be interfering with the other guy. So this is really important to pick out because you don't want to, you would destroy or you would ruin this piece in cutting this piece. And same thing here, you would ruin this piece by cutting this piece. So let's go back here, hit that plus arrow. So now here's all your controls again. So as we went through the control geometry, we went through identifying what tool you're using, what the diameters are, the feeds and speeds, clearance. These are all the tabs that were across the top. So I want to go back to parameters. So I'm going to click on parameters. And so here's my tolerances that we went through. Here's it's spinning as a conventional cut. We go back to, there's our cut feet, or there's the depths of cut. And then our entry and exit. So now if I go back to none and none, and then generate again, watch what happens to those guys there. They go away. So the bit comes over. That's what this red line represents, is the fast motion to the next cut. So it comes over, does its operation, goes around, comes back, jumps over to this guy, does its operation, goes back over. So this red line, the red line represents the rapid motion from cut to cut, and the light blue line represents where the bit is traveling. So a lot of times you'll be, one of the things that's really important to check, especially when you're doing little pieces that are next to each other. A lot of times the bit doesn't know, or the computer doesn't know what side of a part you want to cut. So say, I'm going to do something here. So say you have a cut, say you've programmed all this guy, and you look through these guys. Okay, so here's the part that I want. The blue line's on the correct side. This guy's on the outside, so it's giving me the finished part that I want. The yellow line is your finished part. But then you look at this guy and you go, wait a second, this one's on the wrong side. And the computer doesn't know what side you want. Once you get into these guys, or it's a large part, it usually guesses pretty good, but you got to go through and check, or you're going to waste a piece of material, because this guy is now going to be 3/8 of an inch or 3/4 of an inch smaller than it should be because you cut on the wrong side of the line. So here, what we want to do is this guy. As we go through these, we see, okay, all these are good. The light blue lines on the outside of the part. So we highlight this guy, and then we just type in flip, F-L-I-P. And you see how there's the command I just put in, flip, and you hit enter. Flip, enter. And then I hit regenerate. Let's try it again. Flip, enter. So see how it was cleared. This red means that there's an error. So because I've changed something, so now I right click on this guy on the top part here and I say regenerate, and now this guy goes back to the correct side, and all of the. So you definitely want to make sure that as you go through your components, you check to make sure that that light blue line is on the right side is on the correct side of your part. So that's really huge. So from there, we know we've got this is our first part. So what we're going to do is we're going to right click on that, and you can see this part that says post. I'm doing this video on a machine that has a temporary license, so we won't actually be able to post off of this. But I would click on post, and I'd have a thumb drive in our USB deal here, and this post here is the cannot post while running a demo mode. But I would post that to the thumb drive, and then I would take this tool path out to the machine and then load that on. So that's kind of a long version of the video, but this is a good one to for the basics of cutting these parts on our CNCs.